Anyway, so sorry again. So thank you all for joining. Last week we talked about the new items for the roadmap, the new use cases, Fabric.before. I sent an email asking Brigade members to sign up to the different working groups, and this is the status. So thank you all for replying to that. There are more working groups and areas than what we discussed last week. Last week we discussed mostly about Fabric.before, INT, before runtime support, yes, documentation. Now, as you can see, we have 6 different areas working groups. No one signed up for documentation. Just not understand.
Not surprising.
It's not surprising. So in this case, I ask everyone to please try to document in some way what you're working on. So for the people working in the P4 runtime working group, we should commit to at least update what we have on the wiki. Same for people working on Fabric.before, INT, GenMI support, and that's all. I just talking about briefly. There's a working group that we didn't discuss last week, which is Bsc Demo, which is it's let's say a working group we created specifically for 2 Brigade members that are Phil and IB from EdgeCore. They're going to help us. Basically, as you know, EdgeCore produces a switch based on the barefoot to finish chip, and they will help us build and maintain a POC that they can use to be a POC of ONOS, controlling the switches using P4 runtime. They can show to their customers. Briefly, also, I want to mention about this owner you see in the different working groups. The owner is basically a person for each working group that is, I don't want to say responsible, but that can provide enough support, enough guidance to make sure that each working group delivers what we commit to deliver. As you can see, I'm going to be the owner for the P4 runtime support. Brian O'Connor is going to be the owner for the GenMI working group. I don't know if he knows. I just promoted him owner. I'm going to be also the owner for the Fabric.before effort because there's a lot of, let's say, Fabric.before. It's at this moment it's the as the highest priority in the roadmap, with E being, let's say, the technical reference for this working group. He's the one that has been working a lot on the on Fabric in general, and along with John Wan, they've been working also on the first draft of the P4 code. Serkan's going to be the owner of the INT working group, and then for the remaining working groups, there's no really need of a owner. It's mostly for the unit test, for example. I don't think it's worth setting goals there. So this is the status, right? So if you are owner of a working group and you want to know who's working with you, here you have the names and the emails. Okay, so next item in the agenda is Fabric.before. Now, I would like to already give some tasks to the new members of this working group to work on. Some practical tasks, but this is not the case. We are still trying to, let's say, figure out what the work that we need to do to accomplish Fabric.before. We know that this is, as I said before, just high priority. We're planning on having a first, POC of Fabric.before, working support by beginning of December. It's a very tight deadline. But we're still trying to figure out how to organize the work in a way that we can parallelize it and work incrementally. So what I prepared is a document that you can find here with a list of pointers that you can use to get a grasp on what Fabric is. There are links. There's the first one is a presentation, is a YouTube video. So just to start with this, then there are a bunch of links to the wiki and explaining what's the Fabric. with some low-level details like the fabric design node. There's a repository in GitHub where you can download some minute scripts to try fabric on your laptop. There are some presentation explaining about the full objective API and architecture in ONOS, which is very important in this work. If you remember Yi's presentation from last week, that's where we're going to work mostly. We're going to write P4 code, and we're going to write the driver for that P4 code that in this case is the pipeliner. So if you're not familiar with this part of the ONOS architecture, I really suggest to have a look at these slides. And then we have a set of slides about P4 support in ONOS, a presentation and a design document of the first draft of fabric.p4 that Yi's and Jongwon have been working on. And then there are some links to the existing segment routing application, which is the one controlling the underlay part of the fabric and the current OFDPA pipeliner. So as a first task for the member of this working group, I suggest, if you're not familiar with this work, to go have a look at these links, get a grasp of everything, ask questions on the mailing list. And then, if you feel brave enough, you can have a look at this patch in Garrett that I think it's still a draft. So if you can make that public.
Yeah, I'll make it public.
Yeah. So in this patch, you will find a first draft of the P4 code implementing Fabric that is documenting the design nodes that you can find in the pointers. It would be great if you can have a look at the code, trying to understand what's going on. If it's not clear, please ask questions. If you see bugs, please help us review this part. And hopefully for the next Brigade call, we'll be able to come up with a more definite set of tasks for everyone. Yeah, I think that's all for this part. Is there any question? Do you guys want to add anything to this part about Fabric?
Do you foresee any coding task for fabric.p4?
Yeah, definitely. Good question. So the coding, so there have been already some coding at the P4 level, and we have some confidence about the P4 code we have right now. So probably we will need some few minor modifications there, but most of the coding will happen at the ONOS level. Maybe I can show you something.
Is that the code you demoed in the layer 1, 2, 3, or something else?
Oh, it's something else. What we demoed layer 1 to 3 was a different P4 program that was provided by Google, Tor.p4, that does different things than what we need to do in the core fabric.
But
yeah, okay.
To integrate on this, the idea is that it will be a lot less effort because we already have the P4 runtime support. It will just be a matter of writing some classes that are specific to the program.
Yeah. So if you're familiar already with the architecture of the P4 support in ONOS, you have this concept of a pipeconf. A pipeconf, brings in together a P4 program and let's say an extension to the driver that lets ONOS understand that P4 program. So there will be a lot of coding related to the driver, which is what we call the pipeliner today. If you look at the pointers here, you can find the existing pipeliner for the OFDPA, for the Broadcom's OFDPA pipeline. We're talking about like 3,000 lines of code. There's a lot of complexity in this part. So what we're trying to do right now is trying to find a way to, get some modularity there and avoid creating another like huge monolithic pipeliner for the P4 case. So there's going to be a lot of coding in this sense, and just to give you an idea of the way we're planning to split the work. Fabric today is it's controlled by many different applications. I think it's 6 right now. You can see 3 here, but there are more, like Underlay Control, Underlay Control,. We'll start by focusing on Underlay Control, Underlay Control provides different capabilities at the data plane, like bridging, routing, line support. In the future, we will like to support things like pseudo wire. The idea is to start simple with providing support for just bridging, then we'll move on routing and so forth. So on. So for each of these tasks, there will be definitely coding efforts, mostly at the ONOS side, the pipeliner, the driver, because again, the goal here is to keep using the existing control application. So what you see here, right, and only change the clearly the data plane code, so the P4 code, but also the driver. So we don't want to change the applications. We want to make sure this new data plane, change is transparent to the application.
All right, thank you.
So for next week, we'll try to come up with more concise coding tasks, at least to get up to speed.
One thing that would be of interest, I think, is that Jongwon here is developing some tests.
Yeah.
That we will use, and those tests run on the current Trellis fabric, OFDPA based, and we will use the same tests, changing some Mininet scripts to test the integration we are doing with fabric.p4, so we know that the result is the same. Yeah. We know what's expected, and we want to achieve that.
Yeah. Yes, and also we will have implicitly an integrated environment to actually test what we're working on. Yeah. So, for example, one of the tasks for next week might be, for example, taking the existing Mininet code that is available here. And I'm not sure if Jongwon's tests are based on the existing Mininet test code, but I was thinking of maybe trying to modify this to integrate with BNB2. Or maybe you can tell us more about the test environment next week. I'm not saying we have to do this now, but for example, one of the first tasks could be, help us build a test environment based on Mininet and BNB2. Yeah, that's all for this part. Any other question?
A reminder, next week is cord build, right? So is there still a meeting?
Yeah, we'll talk about this. So next call might not be next week. We'll talk about this at the end. Let's understand if it's still worth having a call or not, since many of us might be busy with cord build. Okay, so if there's not any more questions, I will move on to INT. As you can see, from the spreadsheet, Serkant will be the owner of the INT working group. Serkant is involved in the ACORD project, and we can see ACORD as the entity that will set the requirements for the INT work. And so now, if Andrea, you can give Serkant.
Absolutely.
You can make him presenter. Yeah. If Serkant, I know you prepare some slides to talk about
yes.
ACORD, and what's your idea of INT in ACORD?
Serkant, I made you presenter. You just need to accept my invite.
All right, got it, I think.
Perfect.
Just a second.
Yeah, we can see your screen.
Okay.
Great.
So I try to give you a quick presentation about what is ACORD. This is an old presentation in the ACORD wiki, but I think it's suitable for an introduction. So ACORD is analytics cord, which is actually not a separate flavor like M cord, R cord, and E cord. Its aim is supplying the monitoring as a service. So currently it's implemented on cord 2.0, which is an old version, and unfortunately there is no way to use it with cord 3.0, and it needs to be re-architectured for the cord 4.0. And then because there are lots of changes between the versions, as far as I know. So there are some architectural discussions going on right now in the ACORD side. And so the goal of the ACORD is enabling observability and closed loop control based on analytics. And the important thing here is the programmability. And if you didn't hear the term closed loop control, the term is used mostly in electronics or mechanical system. As an example of a closed loop control system is all you know, the cruise control system. It's a standard feature on most vehicles on the road. Basically, driver provides the desired speed, and the control system in the car monitors the actual speed and adjusts the engine throttle accordingly. And this relationship optimizes the engine performance and the fuel efficiency. And the examples for ACORD, we can think we can scale in and scale out of applications based on the traffic. And another example can be SDN flow routing based on the traffic load. So an application can reprogram the path for the load balancing the traffic. So this is the high-level architecture of ACORD. As you can see, there are three main parts, functional blocks in the ACORD architecture. So the monitoring as a service in this layer, in the middle layer, it decouples the analytic engines and the probes and provides a unified interface to program and observe hardware and software probes also. And also it includes the scalable time series data storage for the traces of observed data and the result of the analysis. So in this layer, there are probes. These are programmable probes. Can be run on any targets, such as on compute nodes, switches, ROADM devices, etc. And the upper layer, we can put any application, and those are the analytic engines. We can write real-time applications on this layer or security applications. And for example, you can implement a DDoS application here, and it observes the data and control the decisions. So this is the closed loop actually. Oh, I think I can skip this. This is inside the monitoring service, which is the middle layer. Here you can see there are some defined functionalities which are data collection. We can have different plugins. For example, we can have OpenConfig collector or VS collector or SFlow collector, you name it. And also the probe configuration holds the inventory of the collectors and also configuration plugins. We have a data delivery part here. It's basically a data bus which has a pub/sub interface and also a query interface. And the data storage is TSDB. And we can write analytic engines on top of the monitoring service. I think I can skip this also. So what has been implemented in real life? The team leveraged Celometer. They took the Celometer from the OpenStack project and modified it and deconstructed Celometer into subsystems and put into the ACORD, and also Also, the plan was to implement the S-Flow as a service, but as far as I know, it didn't end. And currently, as I said, if you want to deploy a core, we need to use core 2.0, which is an old version. So also the Telemetry uses the MongoDB as TSDB. So in a core there's a MongoDB part. And you can also subscribe this message bus, Kafka message bus, and get the notifications over Kafka. So this is all I want to explain about A-Chords. If you check out, I'll send the link via chat, the presentation link. And any question for this part?
Yeah, maybe I missed that part, but is there any plan to move to Core 4.0?
Yes, there's a plan, but as I said, there are some architectural discussions going on, so there is no strict plan right now.
Serkan, sorry, just a question. Will you be at Core Build?
Yes, I will be.
So maybe just brief discussion with us during Core Build itself could be a good, interesting point. Because,
yeah, sure.
Well, one of my thoughts is that we should build two components for this INT effort. One that sits in Chord, which is part of A Chord, and that component will in turn drive an ONOS component. But that ONOS component should not be dependent and tied to the A chord component inside chord. What I mean is that it could be used independently. Did I make myself clear?
Yeah, I am agree with you.
Okay.
Okay, but I think we can implement an application, but it's maybe just for POC or demo purposes.
Mm-hmm.
Why?
Why? I'm not sure, but without a service as a I forgot the name.
Synchronizer.
Without a monitoring as a service, it would be a little thing, I think.
But so maybe this is not the right venue, but in my mind, the monitoring as a service is just a driver that asks ONOS to, do something on the network, in this case, inject some type of metadata in the packet, and then gets it through on the other side. So what I probably see is that injection part of the packet is a call in ONOS, and that call in ONOS shouldn't care if it's the monitoring as a service that uses it or somebody else that uses it.
Yes.
So
and also,
yes, please.
Yes. And also, you are suggesting that we need to have an application uses the ONOS to show the INT use case.
No, I'm not. So I think that the technical elements of INT will be implemented in ONOS and should be at least driven by an ONOS application. The whole UI side and controller side and probes and the configuration, the inventory, the data storage, that should live outside of ONOS.
Okay.
I think this is a discussion that it's better to have face to face.
Well, I know, Serkan, you had some ideas about architecture. I don't know if you want to present anything. I know you've been working on trying to define architecture. going to present anything about this, or maybe we can postpone this to next week?
No. I have another slide for that.
Okay.
Awesome. Thanks.
You're welcome. Just let me find it. Should be here. Okay. So I benefited from the Jong-Won presentation. He already summarized some of the tasks we need to do. And I tried to write some details about the bullet points in here. The first bullet I want to talk about is the how to orchestrate the telemetry data and generation collection process. So the question is, how do we able to use how to make applications able to use ONOS APIs to orchestrate the telemetry data, and from the ACORD point of view, those are my thoughts and also my colleagues' thoughts in ACORD. And an application need to subscribe to specific events by using the address of the collector, but ONOS should have the inventory of the collectors so that an application can subscribe. An application need to provide what it needs, and ONOS knows how to provide those data. For example, the IP address of the collector. I wonder here, is there a specific way in ONOS doing the same thing? Is there any utilizable design in ONOS right now? I don't know. Any thoughts on that?
I don't know of any specific service that provides, I mean, any general enough service that provides this kind of information, but I think it's very easy to create your own service that stores, this kind of information.
Yeah, and also, so they had this specific collections application. So basically, you're using ONOS as a sort of single point of request. So an application comes in and says, I want to register for the X collector, and ONOS returns it the IP of the X collector, and then the application goes in and talks directly to the X collector. Is that what you're asking?
Yes. The idea here is there may be lots of collectors.
Yes.
Which is sflow or open config collector, VS collector, and somebody need to have all these configuration. So I think ONOS can be the part of here, holds the inventory of the collectors, and ONOS may provide the which collector, for example, IP address of the collector the application needed.
Well, I'm wondering if ONOS is the right place to do so. To me, this is an orchestration element that should happen inside XOS, but I don't know. I don't know, because in my mind it should be, and maybe please everybody correct me if I'm wrong, but in my mind is, okay, I want INT telemetry with for these specific elements, and the application subscribes to it and says, okay, and it also it subscribes to it, and ONOS says, okay, you're subscribed, and then the application knows where the telemetry collector is. For INT, it can be ONOS. For other elements, it can be another component that ONOS is not aware of. So, I don't know.
Okay, let's discuss this also face to face.
Yes.
Yeah. I also think that, I mean, my vision of INT on ONOS is, as Andrea said, ONOS should offer an API for external entities. I don't know what's this external entity, should offer an API to, for example, configure or push down, the flows necessary to generate the telemetry data and send this telemetry data somewhere to an external collector. So it's the application that's already aware of the existence of an external collector. It just asks ONOS to control the network in a way that those telemetry packets are sent to that collector.
Yes.
That was my initial vision, but we should discuss about this. We should definitely discuss about this.
While Carmelo was talking, I see your point about the application maybe not knowing about this external collector. And maybe ONOS does know because it knows where to push the collection data. So I think maybe we're going a little bit too much into low-level detail here.
Yeah.
But in general, I think we agree on what is the what is the need here. Subscription API, and that API simply enables ONOS to do INT and then push it to somewhere else, to a bus, let's say a Kafka bus, or like a gRPC stream or whatever.
Okay.
Yeah.
So another thoughts on this, the configuration of props. The same discussion maybe goes here, but who will configure the props? We need to discuss this also. Also, we need to understand what type of configuration for the INT use case. We can say, we can tell the P4 program where to send the telemetry data. We need a configuration for that. Also, P4 program need to know is it a sink or source based on the flow type. And the collector shouldn't be a part of ONOS. I think we are all agree on that item. We need ONOS as an enabler for services that want to be a collector.
Before you were mentioning OpenConfig collector, just out of curiosity, is there anything out there that is open source? I'm not very familiar with this word.
Yeah, I think there's an open source project under OpenConfig GitHub repository, but for the telemetry part, it is very new, and I didn't look for what they have done.
Okay. And do you already have an idea of what this probes will be? Like, say, I don't know, like I want end-to-end delay for certain flows, or what are the metrics you have in mind here, just to understand?
Oh, for the P4, we can collect Q latency metrics and the switch metadata, switch ID, and
switch ID. You mean all the switches that were crossed by a pipe?
Yes.
One thing that comes to mind and that I'm familiar with the eCode project is the OAM CFM layer 2 monitoring. I don't know if you're familiar with that.
No, I'm afraid I am not. Could you please repeat the question?
So in the eCode project, we have some integration with the OAM layer 2 monitoring.
No, I don't know about the eCode projects. No,
but so OAM is a standard for layer 2 monitoring. So we could just take inspiration also from that one. It basically enables you to have measurements of end-to-end delay, end-to-end jitter, and a lot of other subset of this. And I can maybe share some document, and we can think about this. It's just a thought. We could reproduce some of those functionality our level.
So you are saying OAM, right?
OAM/CFM.
CFM. Okay.
Yes. And if you take a look in ONOS, there's already an application called CFM.
All right. All right. Okay. The other bullet points in here, external collector. So here are my thoughts on that. External collector should be capable of collecting statistics from different sources. These can be OpenFlow switches, P4 programs, VNFs. And one problem here is ONOS already collects OpenFlow statistics. So if an external controller also wants OpenFlow statistics from an OpenFlow switch, and I think there is a way to collect those metrics, but I am not the exact way of this. And also we, as I said, we'll need different collectors, but for if we implement external collector, by the way, in the external controller we need to have OpenConfig P4 collector and VS collector. And external controller should be capable of a public subscribe interface so that any application subscribe to a specific event. And the important points, a collector should expose an API for lifecycle management, and lifecycle orchestration should be done by an external orchestrator like XOS. And if you want to make a demo for external controller without waiting for ACORDs, we can simply utilize DCAE with some specific modifications. This could be GNMI, OpenConfig. Carmelo, by the way, you mentioned we will also have some GNMI tasks in this brigade, but there is no work group for that.
There is no what?
Work group.
Yeah, there is a working group. We have few people here at ONF that are working on GNMI support, like Andrea, mostly Andrea, Brian. Yeah, and we're still in a exploratory phase. We have some ideas on how we want to do this, but there is a working group. There is no code yet.
Yeah, we should maybe look at this, but I think the integration with GNMI is a little bit out of scope for this moment, for the collection of data.
I don't know if it's out of
maybe
scope.
more statistics.
I mean, in the P4 API working group, so they're talking about using GNMI for things like configuration and telemetry streaming. So I think this is really in the scope of, let's say, the P4 runtime work we're supporting.
Yes, what I'm saying is not.
But I think we need to rationalize this and figure out if we're trying to build that INC, at least for this part, or if we're trying to use GNMI as the telemetry, right? Let's focus on one initially.
Yes, that's what it is.
Right? And I think my concern, what I'm hearing is, it seems like there's a lot of focus on trying to build out a POC for some sort of demo. So I'd like to better understand, are we targeting a demo in a certain time frame? It feels like we're trying to possibly do some shortcuts to support that. So I'd rather make sure we focus on the right thing and understand what we're targeting.
Oh, all right. Those are some thoughts, but if we want to implement an external controller to show something as an outcome of this brigade, probably we'll need an external controller, and we can utilize something in open source.
So Anis from Google did a talk about the open config stuff and open source collectors at one point. So that was one area, but I think that was very focused on GNMI, right? And then for the A-Chord stuff, you had talked about an analytics engine. So where did you guys see collectors as fitting into that picture? Because it feels like it should move towards kind of building out the A-Chord plan and architecture, right, as we head further into this. So where were you guys seeing collectors being hosted as part of the A-Chord?
Oh, poop, poop, poop.
Right, so how does this fit into the overall A-Chord vision? I think I'd like to better understand.
So the collector part is in the monitoring as a service layer, which includes some plugins here.
And is the concern that in order to have something available near term, trying to build out monitoring as a service and analytics engine would take too long?
Sorry, could you please repeat?
So it seems like there's, as part of monitoring as a service or A-Chord, there are plans around data collection, but you've been proposing lots of other collectors. So I'm trying to understand what's the plan. Are we trying to build out integration with INT and A-Chord, or trying to build something short term just so that we have a UI to demo this?
I'm just trying to build in short term, but the outcome of this work also can be an income for the A-Chord and vice versa. We can use the resources from the A-Chord team also for the data collection part.
Okay, so maybe it would be good to understand, and part of it could be discussing kind of the plans around how we want to approach this then.
All right. So another topic was, by the way, am I running out of time? I think. I'll try to be fast. So another question, finding a way how to check INT capability of the pipeline. So basically, as far as I know, if you register to device listener service in ONOS, probably just tell us if the device is P4 capable or not. In OpenFlow, the same problem there was in OpenFlow. The OF config protocol is defined for capability discovery, and as far as I know, nobody using it right now. And the same problem here for the P4. How can we understand if a device or pipeline supports the INT? We can, two options here. We can just define a header in P4 runtime to understand if the device has INT. And also we can ask the P4 any thoughts on this problem.
Okay, so very good point. So regarding how to understand from the ONOS perspective if a device is capable or not, you can do this. You can query some service and ONOS that tell you if the device is P4 capable or not. So about the INT capability, that is tricky, right? Because what is INT? So from the P4 perspective, INT is not just a binary capability. It's like it supports INT, it doesn't support INT. So INT is a specification mostly of a packet format that switches exchange to understand which telemetry data should they append on the data packets. But the way INT is implemented in P4 is not really standardized. There are some proof of concept P4 programs, some sample P4 programs that define the structure of the tables and the parser and the processing you need to apply to packets to read telemetry data from the switch, push that to the packet, right, and forward it. So in this case, I think that ONOS should play a role. Like in like in the presentation from John Wens last week, what I envision is, I mean, in ONOS we should provide a sample INT program. So a P4 program that provides very basic forwarding capabilities. On top of that, it provides also INT. And the idea is that we build support for that specific way of, let's say INT pipeline. What I mean is that at the end of the day, to generate the telemetry packets, to define who's the source, who's the sink. Mm-hmm. So the telemetry information you have to insert table entries in a P4 pipeline. So what I'm suggesting, at least as a first task, or in the first phase, is to define our own INT pipeline, in which we don't really care about the forwarding. We make the forwarding very simple, say, I don't know, layer 2 switching or layer 3 routing. But most important, we define our own INT tables. And if I understand well, John 1, there's going to be 2 tables, one to define to push down the telemetry information, and one to pop the telemetry header. Anyways, 1, 2, 3 tables, I don't care, right? And we provide support for that specific pipeline such that other people that are interested in using INT, for example, we might integrate INT in fabric.p4. What we will do is take fabric.p4, the P4 program, and extend that with the same INT table we defined before. And then we provide some mechanism in ONOS to wire, to make the INT subsystem understand which are the tables to control to achieve, telemetry collection process.
So what you're suggesting, Carmelo, is that we find a finite set of headers and elements that we want.
Tables.
Yes, but also we have to define inside the tables what to inject in the packet for INT.
Yeah.
So we also need to define the finite set of elements we want to be able to inject and pop from the packet. And that becomes a de facto ONOS standard.
It's we say ONOS supports this way of doing INT.
Okay.
This is a starting point, at least for a POC. It can work.
Well, then this aligns perfectly with.
I don't know if my explanation was clear, Serkant.
Yes, it's clear.
Okay.
And it's simple in short term.
Yeah, we're kind of like running out of time. I don't know if you have any other slides to discuss or maybe...
Just another 2 minutes for me.
Okay.
Okay, so another task is to implement int.p4 in P416. Jonk1 knows that part, and also we need to implement an ONOS application, and also in the long term maybe we need to find a way to inject int p4 to another p4 program. Example of it is fabric.p4. And so probably Jonk1 knows how to do that, but I don't know, how do we install flow rules for INT? For example, if we want to start collecting from source IP address to destination IP address, how will I be able to say that? And it's another point in my mind.
I have a quick question on a way to inject INT to another P4 program. Do you see that happening at runtime or at build time?
No, for build time.
I would say this is very forward-looking.
Yes, for sure.
This is very forward-looking. I suggest this is definitely an interesting question. We have something like this in the roadmap of the Brigade, like generation optimization of P4 programs. But I suggest to
light years ahead.
Yeah, especially considering we're running out of time. Regarding how to install flow rules on INT, I think this is where the Jonk1's previous work, right? Yeah. The INT mon comes into play because we already have code that does that. There's an API, there's a nice UI. I just wanted to talk briefly about 2 points before ending the call. I don't know if Serkan, do you have any other slides?
I can skip over this one.
Can you? Yeah. By the way, can you then put the link in the agenda to the slide set?
Sure. Yeah.
Okay.
So these would be our next short-term actions for the INT group. So we need to start the requirement discussions, create a backlog, and start design phase. And we can parallel start implementing the INT ONOS application and rewriting the P416.
Okay.
So these are the next short.
About P416, let's talk about this. You might find some issues. P416 is a very recent language. I'm not sure that existing compilers fully support that language. So, and from the ONOS perspective, we don't really make any distinction between P414 and P416. What we care about is the P4 runtime API, and yeah, that is
Okay, good point.
Version of the language. So let's talk about this. Can you make me presenter, Andrea?
Yes. One last thing. If the design phase, we can maybe have a meeting during code build. Just throwing that out.
Yeah.
As an idea, maybe we schedule an hour or a couple of hours during code build. I'm making Carmelo presenter to finish up the call. Thanks, Srikan.
Thank you.
Yeah, thank you very much.
You're welcome.
Carmelo coming up.
Okay, so very briefly, there is a patch in Garrett about this big abstractions of the existing PI framework. If you want to have a look at that, if you want to help us review that, I suggest not to look at the diff, but just start from scratch, look at all the PI models and runtime APIs. And it's especially important for the members that are willing to help us writing unit tests. I'm going to submit a patch soon in the next days with the implementation of those interfaces. This could be an initial task for the unit test working group. So writing down unit tests for that implementation classes. And in this case, feel free to reach out to me or write to the mailing list. I suggest directly write to the mailing list such that other people can help. Regarding the next call, is there any objection about skipping the next call and instead having some face-to-face time during court build next week? Let's put it this way: who is so I know Serkant will attend court build. Is there anyone from Netsia attending court build?
Mesut, but he is not in this brigade.
Oh, okay. I don't know. I think so. For us, I think it would be better to skip next week call because we'll be pretty busy with court build. So yeah, in this case, Serkant, we should set up some time to discuss. And if there's anyone else from the brigade attending, I know the guys from EdgeCore, Phil and Abby, they're coming. Yeah. So yeah, we'll skip next call and we'll talk again on GoToMeeting in 2 weeks. And Serkant will schedule some time for next week, right?
All right.
Okay, so thank you everyone.
Thanks everybody.
Thanks.
Thank you.
Thank you.
Thank you.
Have a nice day. Bye bye.
Good evening.
Okay, bye.